this is the systems thinking summary for the remote sensing module for the ENFUSE labs. Okay, so the first key aspect of system thinking is to think about the mission that you have, the goals, and their relationships to the design objectives. The mission that we had for this module was to realize a remote trigger for a camera that's going to go on a balloon sat and fly into the atmosphere to be able to take pictures of an area, for example, a disaster area. In order to realize this mission, we had to learn about the 555 timer integrated circuit. We learned how to build a circuit that uses capacitors to adjust the output of that IC, and we learned about being able to control the frequency of that circuit, the duty cycles, etc. For the system-centric constraints, the second point on this slide, we need to consider all of these different kinds of effects that our system can have. The most obvious ones for this particular system is that it is addressing safety concerns because it, like I said, one potential application is disaster relief. There are also environmental concerns. For example, what happens to the balloon after you let it go? It goes up, takes the images, transmits the images back down to Earth, but where does the balloon go? Can you recover it, and what effects will the electronics and the balloon itself have if it just falls back to Earth and you can't recover it? This kind of has an aspect in this cradle to the grave costs. So when you're making the electronics and the other components that are go into the balloon set, that's taking up some resources, has some environmental costs, and then when you're operating it, maybe the costs are nominal. It's not that expensive a system, but there's other costs at the end of the lifetime, which would be like the environmental impact of having these things degrade into the environment. And especially looking at some of the electronic side, for example, when the components are soldered onto the boards, is that solder lead free, or if it has lead, is that going to end up leaching into the environment? The third aspect of systems thinking is performance metrics and how they're going to relate to cost and benefits. So from this module, we looked at, for example, designing the interval over which this camera is going to take photos. There are some trade-offs. You can take a lot more photos more quickly, but then you might fill up the storage space in your camera. There's also the size, weight, and power of the camera, or SWAP, and we talked about this in terms of satellite design. It's very important that you want to minimize the size, minimize the weight, minimize the power requirements for things that are going to go on satellites, or in this case like this weather balloon kind of platform. And also the image quality. So of course we want the highest resolution images possible, but that may mean that your camera is heavier or larger or requires more power. So all of that plays into all of these costs and benefits. For 4, we looked at design layers and appropriate models at each layer. So for example, here is a model of the 555 IC, but we didn't really focus on this because it's not an appropriate model. Instead, we looked at the 555 IC as more of a black box here, and we looked at the external circuit that we build around that, and so that we can program the frequency of its operation. The fifth thing is the subsystems and how the components interact. And the sixth point is the flows of information and power, and how the layers are interacting. So these two were addressed when we looked at the overall system of the balloon sat, the electronics on board, and how each of these things interacted. So power is all connected by these red lines. So from the power supply, we have all of these, we're powering up all of the electronic components here, and the flow of information was these represented by these blue arrows. So the CPU basically is sending information to each thing and calling back information. So for like the GPS will report to the CPU where you are. The camera will feed back images to the CPU once the CPU tells it to take a picture, and so forth. And finally, the last aspect is conflicts that result in design trade-offs. Now this has to go back, we go back to the performance metrics. So again, the interval that we were taking photos, the trade-off was we can take a lot more photos by having much smaller intervals, but then you have much more storage space requirements. Size, weight, and power, that's a trade-off, because if you want a better camera on board, then you're going to have to increase size, weight, and power, and cost is another factor to this as well. And then image quality, again, better camera, higher image quality, it's going to be heavier, going to cost more, be bigger, and use more power. And also, you may be able to take photos at less frequent intervals because you're going to start to fill up your onboard memory faster. So I hope you enjoyed this module on remote sensing and this lab where you use this IC and looked at the AC signals that you could get as a result of the external circuitry.